Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R Software. So from this lecture, we are going to start our discussion on a new topic, which is about the association among the variables. And in this topic, basically we are trying to study the different types of relationships which are existing among the variables or say between two variables. For example, in case if I say, suppose if I take the example of height and weight of the say this young children, right? We know that when the child is born and then up to a certain age, the height of the weight increase together. That means when the height is increasing, then weight is generally increasing, and when the weight is increasing, generally the height is also increasing. Similarly, if I try to take one more example, you have seen when the temperature of the day increases or the weather temperature increases, then the consumption of water, consumption of electricity also increases, because then people are using more devices like air cooler, air conditioner, etc. And similarly, if the temperature is also decreasing beyond a normal threshold, then also the consumption of electricity increases, because people are using lots of heating equipments. In another example, if you try to see as a student, if you study more, then you get more marks in general. So if you try to study in all these things what is happening, that there exists some relationship between two variables. Yes, this relationship can be extended to more than two variables also. For example, the yield of a crop. This is depending on several variables like as temperature, moisturizer, quantity of fertilizer, soil quality, etc. So my idea and my approach in this topic will be how we can determine if there exists any relationship between two variables and how to quantify it. So there are usually two types of tool. One is a graphical tool and another is quantitative tools. So gradually in this lecture and in the forthcoming lectures, we are going to discuss these graphical and analytical tools to understand the relationship existing between or say among variables. So first I will try to take up the issue of graphical presentation. Graphical presentation means that when the data comes on say two variable or say more than two variable, then usually you will see that one variable is going to be affected by another variable. So we would like to see graphically if there exists any relationship or not. And then based on this relationship, we will try to take one step more and to find out the different quantitative measures like as correlation coefficient if there is a linear relationship. And further, we would like to fit different types of statistical model using principle of least square, regression techniques, etc. So the graphical techniques, they are the first step to determine if there exists any relationship or not. One thing I would like to clarify in the beginning itself, that broadly we can divide this type of relationship into two categories, linear and non-linear. So based on the nature of this relationship, we decide on the first hand that whether there exists a linear relationship or not. But I would also like to clarify that there is a concept of linear models or say linear regression models in statistics. So, the definition of a linear model is quite different. A model is said to be linear when it is linear in parameters. So, there is no guarantee that if you find a non-linear type of relationship or some sort of curvilinear relationship, then there is a 100% guarantee that there exists only non-linear relationship. So, I am not going into those details over here, but my modest objective in this lecture and in the next couple of lectures is to take up different types of graphical tools and to show you how you can use them to determine the nature of relationship and how we can execute them in the R software to create different types of plots. In R software, you can create various types of plots, but here I am going to take only some representative plots. And I am sure that the creation of those graphs and understanding from those graphs will help you in understanding more graphics. So, let us begin this lecture and try to understand that how we can create a scatter and smooth scatter plots in the R software and what is the concept behind it, how do we read a graph. So, let us begin this lecture. So, now if I take up the concept of association of two variables, then we know that there are several examples by which I can explain you what is the concept of association of two variables or more than two variables. For example, the numbers of hours of study affect the marks obtained in any examination. And similarly, the electricity or the power consumption increases when the weather temperature increases. Right. The weight of infants and small children increases as their height increases under normal circumstances. Well, I would like to clarify here that first I am going to discuss here the relationship between two variables. So, I am taking this example, but in the same example the outcome will also be dependent on some other variables. For example, the marks obtained in the examination, they also depend on some other factors, right? Right. Similarly, the power consumption also depends on many other factors. Similarly, the weight of children or the height of children, that also depends on several other factors, right? But in order to keep the discussion simple and easy to understand, I will consider here only two variables, right? So, what we assume here that there are two variables which are dependent on each other or they are associated with each other. Now, how to know that these variables are related to each other? So, if the variables are related to each other, this means that the observation on these variables will also be related to each other. So, now the question is, based on these sets of observation or based on this sample of observation on these two variables, how can we know that the variables are related and how to know the degree of relationship between the two variables, whether the association is very strong or the association is very weak and so on. So, in order to address these issues, there are two approaches, graphical procedures and quantitative procedures. In graphical procedure, there are different types of graphics and plot in 2 and 3 dimension which can help us, right? What you have to keep in mind that whenever we are trying to create the graphics as a human being, we have the limitation that we can create the graphics only into 2 dimension, but through different types of visual effects, we try to give them the impression of 3rd dimension also, right? So, we will try to see these graphical procedures. And when we come to the quantitative procedures, there are several concepts which gives us an idea of the numerical values of the degree of relationship, like as correlation coefficient, contingency table, chi-square statistic, linear regression, non-linear regression, etc. And depending on the nature of variable, whether the variable is continuous or discrete, we try to use different procedures, right? So, now let us first consider how to judge graphically that whether there is a association between two variables. and this has to be judged on the basis of sets of data. Suppose there are two variables which we are indicating by, say, this capital X and capital Y, and we have obtained n pairs of observation which are denoted as x1, y1, x2, y2, xn, yn. What does this mean? Suppose I have here 5 children, and I write down, say, them as say C1, C2, C3, C4 and C5, and suppose I measure their height and weight. Right, suppose it comes out to be here 30 centimeter and the weight is 2 kilogram, right? And suppose there is another child whose height is 35 centimeter, newly born, right, whose weight is 2.2 kilograms and so on. So if I say here that x is my here height and y is here weight, then the value of x1 is 30 centimeter and the value of y1 is 2 kilogram. Similarly, the value of x2 is 35 centimeter and value of y2 here is 2.2 kg and so on. So these are your here observation. So this x1, x2, xn and y1, y2, yn, they are say in lowercase alphabets. These are some numerical values. Right. Now, the first thing is this, how do you get the information, or how do you read the graphics? That is very important, right? So, one of the most simple graph is the scatter plot. So, what we do, we plot the paired observation in a single graph, and this is called as a scatter plot. So, what do you mean by paired observation? So, paired observation, if you try to see, you are trying to take here, suppose the first child, and you write it's the height of first child and the weight of the first child. Similarly, for the child number 2, you try to write down the height of second child and weight of second child. So, these are the observation which are corresponding to child 1 and child 2, and these are something like child 1 is having 2 observations on 2 different random variables, and similarly the child 2 also is having 2 different observations on 2 different variables, right. Now, these scatter plots actually reveal the nature and trend of possible relationship, and this relationship can be linear or non-linear. Once again, I would say I am not talking about the linear models and non-linear models. I am simply trying to discuss here the relationship between the 2 variables, which can be linear or which can be non-linear. So, how to determine it on the basis of a scatter plot? So, in the scatter plot, what we try to do here, it is like that on the x-axis and on the y-axis, we will try to plot these points, say x1, y1 somewhere here, then here somewhere here x2, y2, and somewhere here, say here xn, yn, right. So, this is called here as a scatter diagram. So, if you try to see here, suppose I am taking here some points. Yeah, first I am trying to explain you how are you going to take the readings from the graph and how do you take a decision. If I take here, say this x and y axis, and we try to make here this type of here diagram. So, you can see here all these here dots, they are indicating the paired observations, right. So, you can see here all these observations are lying in this a small group, and they are indicating that as the values of x's are increasing, the values of y's are also increasing. That is the first thing. And secondly, if you try to see here, if you can possibly draw here a straight line which is passing through with the maximum number of points, and the remaining points are as close as possible to the line. So, you can see here that there is here a linear trend, right. Remember, the relationship is not exact, but you can see the linear trend in the relationship between the 2 variables x and y. So, in such a cases, we can conclude that there exists a relationship which is linear in nature between the two variables x and y, or I can say simply that x and y are linearly related. Now, similarly, if you try to look into here this figure, let me call it figure number 1 and figure number here 2. So, in the figure number 1 you have seen the linear trend. Now, in the figure number 2, if you try to see, the observations are plotted which are in blue colors like this one, and they are plotted on x and y axes. So, you can see here there is no linear trend, but if you try to see here, the observations are lying in this type of here band, and in which if you try to see, then the relationship is something like here, and the relationship is like here. If you try to see here, this one, right. So, obviously, you can see as a from your common sense also that the relationship here is non-linear, and the trend of the observations to show the relationship between x and y is also non-linear. So, there is a non-linear trend. So, I can say that here in general that there exists a non-linear relationship between x and y, right. So, now in case if I consider the linear relationship, then how to diagnose it more? This relationship can be increasing, this relationship can be decreasing, and moreover there can be different degrees of relationship between x and y, right. For example, if I say here that the yield of a crop, this depends on the quantity of fertilizer, right. Yeah, means anybody would agree to it. But if I say that the yield of a crop depends upon what is the monthly income of the people living in that village or in that city, right. In this case, yes, you can say in some sense that okay, if people have more salary, they can use better equipment, they can use better quality of fertilizer, so the yield will increase. But then the relationship is very weak in comparison to the nature of variable of quantity of fertilizer, right. And if you try to see that the yield is going to depend on the number of students studying in the school and colleges of that village or that city, then there is definitely no relationship, right. So, this is what we actually mean by this thing, right. So, if I try to say divide this type of relationship into broad categories, say increasing and decreasing. So, you can let me call it here, this is here my figure number 1, this is here figure number 2, this is here figure number 3, and I have here figure number 4. So, from these figures we try to understand. Now, you can see here, first you try to look at figure number 1 and 3, right. If you try to see here, in both the cases, as the value of x is increasing, the value of y is also increasing in both the cases. So, that means I can say that there is an increasing trend, right. Or I say that there is a positive linear relationship. And now, if you try to create here a hypothetical line passing through with the maximum number of points in figure 1 and figure 3 both, what do you observe? You can see that in the figure number 1, points are lying closer to the line in comparison to figure 3. You can see here the difference of these points in the figure number 1 from the line is much smaller than the distance of these points in the figure number 3, right. So, in this case, if I try to compare the nature of relationship between figure 1 and figure 3, then do you think that I can say that there exists a strong positive linear relationship in the figure 1, and the nature of positive relationship in the figure number 3 is moderate in comparison to the figure number 1. Right. So, this is how we try to interpret the strong and moderate nature of the linear relationship. And now, if you try to compare here the figure number 2 and figure number 4. So, in figure number 2 and figure number 4, you can see very clearly that as the values of x's are increasing, the values of y's are decreasing. In both the cases, you can see here. And if you try to see the nature of the scatter diagram, so as in the figure 1 and 3, there was an increasing relationship, and and you had plotted a line. Similarly, in the case of figure 2 and figure 4, where the relationship is negative in the sense that as the values of x are increasing, the values of y are decreasing, and you can plot here this type of here line which is passing through with the maximum number of points, right, here like this. That is a straight line, right. But if you try to see what is the difference between figure 2 and figure 4, in figure number 2, the points are lying very close to the line, but in figure number 4, the points are lying quite away from figure number 4. So, just exactly on the same way as we had defined the strong positive and strong moderate positive relationship in figure 1 and figure 3, similarly I can define here the strong negative linear relationship in figure number 2 and say moderate negative linear relationship in figure number 4. So, I can say that the relationship in figure number 2 and figure number 4 both are negative, and the trend, if you try to see here, is negative. So, that is why there is a negative relationship, whereas in the figure number 2, since the points are lying closer to the line in comparison to the figure number 4, so we can say that the relationship or the linear relationship between x and y as depicted in the figure number here 2 is stronger than the relationship or the linear relationship as depicted in figure number 4. So, this is how we try to understand these graphics from the scatter plot. And similarly, if I try to make it here one more relationship between the x and y observation, so you can see here that these observations are like lying in some area here where there is no idea what's really happening. There is no clear indication that if x is increasing, then y is also increasing, or if x is decreasing, then y is also decreasing, or say if x is increasing, then y is decreasing, or vice versa. So, in this relationship or from this graph, it is very difficult to depict what is the relationship between x and y. So, in this case, we simply say that there is no clear relationship between the two variables x and y. So, now we will study about two aspects of this graphic. One is the direction and second is the degree of linear relationship. So, the direction as well as the degree of linear relationship can be studied graphically and quantitatively, right. So, first we try to understand here bivariate plots, which are the first hand tool to give us the visual information about the nature and degree of the relationship between the two variables, right. As I said, this relationship can be linear or non-linear. So, we will discuss here several examples in this lecture and in the next couple of lectures through different examples. Right. So, first we try to understand how we can create a scatter plot. Right. And then you saw that there are two ways. One is that you can use the base package of R, where we have a plot command, and similarly you can also use the ggplot also to create this scatter plot and different types of plots. So my idea is that I want to take several examples so that I can make you confident that you can create different types of such plots in the base package of R as well as in the ggplot2 package. So first let us try to consider here the plot command. Suppose I have here two data vectors in which the data is stored, right? And suppose I have a random variable x on which we have got the data x1, x2, xn, and y is another paired random variable on which we have got the data, say here y1, y2, yn. So this is essentially a paired data, right? So what we are trying to do in the x data vector, we are trying to store the data on say x1, x2, xn, and in the y data vector, we are trying to store the data on y1, y2, yn, like this, okay? So now I can write down here plot x comma y inside the parenthesis, right? Or there are many other options which can be written or which can be mentioned inside the argument to make this graphic more informative. For example, there is another option here, type. So I can write plot inside the parenthesis x comma y comma type, and this will give us say here different types of plot. And similarly, if I try to use here the option here, say here main, then it will give me the overall title of the plot. If I want to have the subtitle for the plot, then I can use the option here sub. If I want to give the title on the x and y axis, I can use here xlab and ylab respectively, and there are many more options, right, as you have done in the case of univariate graphic also. So the same thing I am trying to extend it to now bivariate graphic. So more details I would say that you just use the help and then try to see what you can do. For example, if you type here help type, then you will get here different types of values by which you can create different types of scatter plots. So let us try to understand this plot command by very simple example in which we have 20 students who have appeared in an exam, and we have collected the data on the marks of these 20 students, and the marks have been awarded out of a total of 500 marks. And we also have collected the information that those students that how many hours in a week they studied. And we know from our past experience that usually if the number of hours of study increases, then the marks in the examination also increase, right? So these observations are like this. For example, a student has got 337 marks out of 500, and the student has studied 23 hours in a week. Similarly, the student number 2 has got 316 marks out of 500, and the student has studied 25 hours in a week, and so on. We have here 20 observation. Well, I can say here, or I will repeat here once again, that the marks of a student depends on many other factors also, that how much time they have spent in the library, how many hours they have played, and so on. But my objective here is very simple. I want to show you if there is a relationship, how we can diagnose it on the basis of graphical tools. Right. So I try to combine all this data into two data vectors. One is here marks, in which I try to store all this data vector here. You can see here this data, whatsoever here is in the first row, this has been stored here in the marks, and the second data vector here is hours, in which we have stored the data of the second data vector. I am trying to explain you because I will be using this example again, right? So here I want to give you the full idea that how I have created these two data vectors here, say here marks and hours. So I have here two data vectors, marks and hours, having 20 observation each, and these are the paired observations. So for example, the first value in the marks correspond to the, and the first value in the second data vector hours, they belong to the student number 1, and similarly the second value in the marks data vector and the second value in the hours data vector, they correspond to the student number 2, and the last value in the marks data vector 450 and the last value in the hours data vector, say hours, they are related to student number 20. So this is how you have to understand, right? Now I try to use here the plot command. So whatever I want to give it on the x-axis, I will write it first and then followed by comma, and whatever I want to depict on the y-axis is written after that. So I try to write down here plot hours, comma, marks. So you can see here this type of graph is coming here. So all these points, these are the points here, they are indicating the paired observations, right? So how it is created? If you try to see here, the first values are 23 and 337. You can see here this is 337 and this is here 23. So what they try to do here? Somewhere they will try to take here 23 and somewhere it will be here 337. Yeah. So somewhere it is here 23, somewhere 37, and you can see here this is the point here 23 comma 337 and so on, right? So this is your here the scatter diagram. Now if you try to look at here, look in this graphic, what do you observe over here? If you try to see, most of the points are concentrated like this, right? So can you see here, or can you conclude here that if there is a approximately linear relationship between the two variables hours and marks? In my opinion, the answer is yes. You can see that there is an increasing trend, right? Yeah, what will happen in case if these points are lying so close to each other, right? That's a different aspect. I will try to discuss it, but in this case, the line will look like this, more closer to these points, and possibly I will say that in that case the relationship is more stronger. But definitely in this figure I can say that the relationship is positive. As the values of hours are increasing, the values of marks of the students are also increasing, right? And now if you want to modify it, if you want to make it more informative, you can use here different types of options. Like if you want to give here a title on the x-axis here, something like number of weekly hours, then I can use here the option here xlab, and then within double quotes I can write down numbers of weekly hours. Similarly, if you want to write down on the y-axis marks obtained, then I can use here the option here ylab, and within double quotes I will write here marks obtained, and this value will come here. Similarly, if I want to write down here the main title like marks obtained versus number of hours per week, then I can use here the option here main is equal to, and within double quotes I will write here marks obtained versus number of hours per week, which will appear here, right? So this is how you can customize the graphic, and there are many more options. For that I would request you to please look into the help menu, right? Okay. Now if you try to see, I have created here a figure in which you can see the trend of the observations is positive, and possibly if you try to see a line of this type will pass through with most of the points. So now if I can create this type of line also in the graphic, then it will become more informative. So this I can do, and I can create a smooth curve between the relationship depicted by the observations on x and y, right? So a scatter plot along with a fitted line will provide information on the trend or relationship between them, right? In order to do such thing, if I want to add here a smooth curve, right? the scatter plot, then I can use the command here scatter dot smooth, SCATTER dot SMOOTH, all in lowercase alphabets. So this will create here a smooth curve also, right? This command scatter dot smooth, the function of this command, the way it is written, it is based on the concept of LOIS, which is actually a locally weighted scatter plot smoothing method, right? I can tell you that in statistics there are different ways to fit the line. In parametric statistical inference, non-parametric statistical inference, and so on. So, and then there can be a linear relationship, there can be a polynomial relationship, there can be a non-linear relationship, and so on. So on the same line, this LOIS is actually used for local polynomial regression fitting. And what we do, we fit a polynomial surface which is determined by one or more numerical predictors using the local fitting. If you want to know the more details about this scatter dot smooth, I would recommend you to go to the help and try to look into the more details, right? For example, there are different options, say scatter dot smooth with here x and y. These are the two sets of data. Then span, degree, family, x lab, y lab, y lim, x lim, and so on. So x and y here, the arguments which provide the data to the x and y. Span is the option or the parameter which control the smoothness of this LOIS. Degree is the parameter controlling the degree of local polynomial used. And about the family, if we say that if a Gaussian fitting is used by the least square, or if a symmetric descending M estimator is used, then for example, if you try to recall when we discuss about the density plots, then we had used different types of options to create the density plot, right? So similar is the concept which is given here by this family. And similarly, if you want to give the label on the x-axis, this can be done by x-lab. If you want to give the label on the y-axis, this can be done by y-lab. If you want to define the limits of the plot on the y-axis, then it can be done by y-lim, and so on, right? So now I try to take here the same example in which we have collected the data on 20 students about their marks out of 500 and the total number of hours studied in a week, right? And these marks have been stored in the data vector here, marks and hours. So I already have explained you that how I have created this to data vector so that you can understand it easily. Right, now I try to use here the command here scatter dot smooth x comma y, where x is my hours and y is my here marks. So scatter dot smooth inside the parenthesis hours comma marks will give you this type of graphic. So you can see here all the points, they are the same as in the earlier case, but now there is a line which is added here. So this line will give you here an idea that whether the relationship is linear or not. One thing I would like to show you here is that if you try to see, this line is not exactly linear, right? We can also add here an exact linear line which is obtained by the principle of least square or the linear regression model. So that I will try to show you later on, but here we are trying to add here a smooth curve actually, right? So so by looking at the trend as depicted by this here line, you can see here that the trend here is linear, approximately linear at least, and you can observe how the points are lying above and below this smooth curve. So that will give you an idea about the strength of this relationship, right? And now, as I told you that there are different types of options are available. For example, span, degree, family, x lab, y lim, and then evaluation, LPass, etc., etc. So I will leave it on you that you look into the help menu and try to expand it. Now, there is one more option to create such a smooth scatter plot. This is here the command smooth scatter. you have to be very careful in reading it. Earlier, the command was scatter dot smooth everything written in the lowercase alphabet, but now it is smooth scatter, there is no dot, and the capital and the S of this scatter is the capital S, that is uppercase. So, this is SMOOTH all in lowercase alphabets, you can see here, and then scatter is SCATTER, in which S is the uppercase and all other letters CATTER are in the lowercase. So, this command actually also produces a color density representation of a scatter plot, and which is obtained through the kernel density estimate, right. So, the command is basically, if you have only here one variable, it will be like smooth scatter, and inside the parenthesis the data on x. If you have say two variables, then there are different options here which can be given here, say x and y, they will be the data, and bin, that is the number of bin, bandwidth, color ramp, NR point, red dot selection, PCH, and you can see here there are many options, right. So, I would just give you some idea that x and y, they are the giving the data on say x and y variables, right, and they have to be of the same length, yeah, because that's a paired observation. Then the parameter here n bin, this is the numeric vector of length 1 in both the direction, or 2 for x and y separately, and it specifies the number of equally spaced grid points for the density estimation. If you remember that when we had done the density plot, then I had briefly told you about the kernel density estimators, which are based on which we try to do the kernel density estimation, right. Similarly, is here the bandwidth, it is a smoothing parameter to control the bandwidth of the bins. Then call ramp, this is the function accepting an integer n as an argument, and it is returning n colors. Similarly, here NR point, this is the number of points to be superimposed on the density image, right. And similarly, here red dot selection, this is the logical variable, it indicates that whether the order indices of low density points, if number of NR points, which is here, NR points are here, if they are positive, right. Similarly, here PCS, CEX, COL, these are the arguments which are passed to the points when NR point is greater than 0. So, they try to give you information about the symbol, point symbol, character expansion factor, and color, right. Similarly, there is one more option here, transformation. This is a function which is mapping to the density scale to the color scale. Then there is here one more option here, post plot hook. This is either null or a function, it will be called after image. Their image is another here option. Then x lab, y lab, they are the settings to give the say this labels on the x and y axis. Then x lim, y lim, they are the numeric vectors which specify the limits on the x and y axis respectively. So, I would again recommend you to please look into the help of this smooth scatter to get more details and experiment it, right. My objective here is to show you how it will look like, right. So, now if I try to create here the two data vectors here, marks and hours, and if I try to make it here smooth scatter this hours and here marks, then how it will look like? It will look like here like this. Now, if you ask me what does this actually represent? So, if you try to see, whenever we are trying to obtain an observation in real life, when I write, suppose when I am trying to use x equal to 2 kilogram of fertilizer, then suppose I get here 10 kilogram of yield. So, my observation will become like 10, 10. Now, if you try to see what happens in the real life. In real life, suppose if you take a plot and if you try to put 2 kg of fertilizer, after some time you collect the yield and you weigh it, it comes out to be 10 kg. But now my question is, suppose if you take the plot of the same size in the same field, or even if you take the same plot and if you put 2 kilogram of fertilizer that is in your control, will you get exactly 10 kilo of field? Or if you try to repeat this experiment, will you get exactly that 2 kilogram with 2 kilogram fertilizer, you will get exactly the 10 kilogram of yield? It is very difficult, but all the values will be closely related to 10, maybe 10.5 kilo or say 9.5 kilo, 10.2 kilo or say 9.8 kilo and so on. So, whatever are the observation we are getting here, they are expected to lie in certain range, and in my opinion by this you can see here the points here are actually now scattered. If you try to see the earlier, I am using the same graph here. So, you can see here this was here the point and this is here the point. Now, these 2 points are here like this and here somewhere here like this. So, you are trying to indicate, well, they are going to lie in certain range, and that is why if you try to see the color in the center of these circles, this is darker, and as you move from the center, the color of this circle is becoming lighter. Right. So, it is trying to indicate that the place where the points are in dark color, the chances that the value will be taken at those points will be the highest. And as the color of this circle is becoming lighter, that means the chances are this that the value of that observation will be closer to the, or say that will indicate a sort of variation in the value from the center, right. So, the value at the center in the darker color is more probable to occur. So, if you try to see here in this case also, if you try to make here a line, it is again it will look like here a smooth linear trend. So, with this type of figure also you get a linear trend. So, if you try to see by, I have taken here the same example, but I have taken here see here this different types of graphics, and my objective was that I wanted to show you that from the same set of data, how are you going to read the graphic and conclude what is happening inside the data. So, let me try to show you here that how these things are happening. Up to now I have not shown you it on the R software, because I wanted to explain you first, and then I wanted to show you at the same shot that how the same data is giving the information from different graphics. So, now you can see here this is my here this marks and hour data. Now, if I try to say here plot say hours and here marks. So, you can see here it will come here like this, right. And in case if you try to interchange these values, so if you try to say plot, marks and hours, then you try to observe these values on the x and y axis, they will get actually changed as soon as I execute it. You can see here the trend remains the same, but now you have to read in a different way, that the marks are on the x axis and hours are on the y axis. So, this is how you can control it. Right. Similarly, if you try to make it here more informative and try to give here some commands on to be plot for the plot to be plotted, something like the title on the x axis, title on the y axis, and the main title, you will get here very easily. And you will see here there are many options over here which can help you. And similarly, if you try to make it here a smooth scatter plot, so, or a scatter plot with the smooth curve, you can see here. Now, if I use this command here, you get here this smooth curve also, right. And similarly, if you try to use this option here, smooth scatter, like this type of graphic, you can see here this is coming here like this, right. So, now you can see here that it is not really difficult to plot these graphics in the R software. You have several commands, several types of graphics, but the more important point is how to read this graphic and how to get the correct information. And as I told you, the data is silent. Data is not telling you that I have this linear trend or a non-linear trend. This is only you as a statistician or a data scientist who is trying to dig out the information from the data set. And in this case, you see, you are simply trying to create these graphics and you are trying to interpret what these graphics are giving you the information. Definitely, it depends on your experience and practice that how good you are in depicting these graphics. It is just like, as I told you earlier, that when two doctors look at the same ECG or EEG or the X-ray or ECG, something like this plots, then they can very easily diagnose what is happening inside the body of the person. And it depends on their experience that how good or how precisely they can diagnose what is happening inside the body. Sometimes you see from the same this report like X-ray or say ECG or EEG, two different doctors take different type of conclusion, right? So this is possible in the data science also, that from the same data set, if you try to make these different types of graphics, an experienced persons can dig out more type or different type of information from there. So my request to you is that you please try to take some data set and try to create here a linear relationship, non-linear relationship. You can do it individually. For example, if you simply try to take some equation like as y equal to 3 plus 2x plus 4x square, and then try to create this data, try to add some noise, and then try to plot it and try to see what is happening, how the data will look like, how the scatter plot will look like. And if you try to make here this different types of scatter smooth curve also, that will give you better idea. So I would request you, please try to take some data set and try to plot all this command and practice, and in the next lecture I will come up with some more graphics. So you practice and I will see you in the next lecture. Till then, goodbye.